Hi everyone. In this video, we're going to do a technical walkthrough of notional leveraged vaults. Notional leveraged vaults is a new framework we're launching within the Notional protocol, where borrowers can borrow via a whitelisted smart contract called Strategy, where the borrowed funds will be deposited into a strictly defined yield generating strategy. So the primary advantage for this is that borrowers can borrow at a fixed rate, fixing their funding costs on one side while pursuing higher yielding variable rate returns in yield strategies. So currently many protocols of this type borrow variable and pursue variable rate yield strategies. By fixing the funding costs on one side, we significantly reduce the user's risk of liquidation or loss, and therefore allow them to use higher leverage and achieve greater capital efficiency. So a quick note about the technical architecture. So every leveraged vault position is going to exist in its own collateral context, isolated from all other vault positions, as well as isolated from an account's normal notional lending and borrowing activity. So you may be borrowing USDC against ETH on notional and have a free collateral position there. Whether or not that position is liquidated is basically isolated from what is happening within each leveraged vault that a user that an account has a position in. So even two leveraged vault positions will be isolated from each other, and each one will be liquidated independently from the other. So the leveraged vault architecture is set up as broken into two parts. One is a set of two contracts, Vault Action and Vault Account Action, which are deployed behind the Notional V2 router with full access to Notional V2 storage. This is sort of the core kind of controller contracts that will manage the whitelisting of vaults, the vast majority of the bookkeeping and for assets and debts across each strategy vault, and all the authentication and authorization for borrowing, liquidation, and a lot of the calculations associated with that. What that leaves are the individual yield strategies that will be whitelisted into this framework. And those will be built bespoke and over time as different strategies present themselves. So the strategy is really responsible for its own business logic. That will be, how does each strategy enter and exit its position? Are there any sort of reward compounding, claiming that's required? Is there, any sort of emergency conditions in which it would need to exit its position? And importantly, each yield strategy needs to consider how it'll be settled upon maturity. So with fixed rate debt, unlike variable rate debt, fixed rate debt matures at a particular point in time. So as vault positions reach maturity, they need to be either rolled forward to a longer dated maturity, or they need to be unwound such that the debt can be repaid. So vaults need to consider how they will unwind their position upon maturity. And lastly, every strategy needs to provide a valuation of the spot price on its yield position, and that has to be flash loan resistant and secure in many ways. So now we'll take a look at the primary user journeys that users of a vault will go through. There are three primary actions that vault users go through. One is entering the vault, the other is exiting the vault. And there are two flavors of exits: pre-maturity and post-maturity exits. And then there's rolling a vault position. So first we'll take a look at a vault account object that we store. So each vault account is defined by an account and a vault. note that all vault accounts are isolated from exist in isolation from all other vault positions and normal notional lending and borrowing. So this has its own storage slot that exists in isolation. So accounts have an amount of Fcash that they've borrowed. They are only allowed to be in a single maturity at any point in time. So each account cannot be partially in the 3-month and partially in the 6-month maturity. They must either be in one or the other. And this is an important restriction of leverage vaults and dictates how accounts sort of manage their positions. And then we have this variable called vault shares, which is sort of a representation of an account's position within an account's claim on the total assets within a vault, and we'll talk about that in a second here. We also have the account set, the account's address set here, and then we have a variable called temp cash balance. And temp cash balance is used to sort of accumulate different cash amounts as we go through a transaction. And so that will always have to be cleared by the time we set the vault account in storage. So that requirement is here. When we set vault accounts, we ensure that they must either have sufficient minimum borrow size or have sort of a dust amount of vault shares and no Fcash. This would signify not having a position at all. If they have a secondary borrow position, again, a vault cannot. A vault can only be in a single maturity at any time, so we ensure that these maturities have to match. Now let's take a quick look at how vault shares work, and we'll do this very briefly. It's something that comes into more consideration during settlement, but let's take a look at that before we walk through each of these user journeys. So a vault state is essentially kind of like the global total bookkeeping for a single vault in a single maturity. So each vault can be in multiple maturities at a single point in time. And so we track sort of the state for each one of those maturities separately. There's a total amount of debt held in the vault in that maturity. Whether or not that maturity has been settled, which is a process that we'll discuss in depth, and it needs to occur post maturity, and it's where we set a number of variables that tell us how to partition out the assets after settlement. There are 3 variables here: total asset cash, total strategy tokens, and total vault shares. So accounts hold vault shares, and vault shares are a claim on asset cash and strategy tokens. So strategy tokens are the risk position of the vault. That is some sort of arbitrary tokenization of the yield strategy that's being pursued. Asset cash is money market funds, C tokens or A tokens held by Notional against repayment. So all assets and debts in Notional are accounted for in this asset cash denomination. So as a vault goes through its life cycle, it'll primarily be holding strategy tokens, yield generating positions for most of its life cycle. And as it gets close to settlement, those strategy tokens will be sold globally across the entire maturity into asset cash, and they'll be sold sufficiently to repay the debt and no more. So as a vault gets closer to settlement, it really resembles a liquidity pool where each individual account has a claim on both cash and strategy tokens. And so we have this sort of accounting scheme to manage that. So with that, we will now take a look at the different user journeys. So there's entering a vault, which we will go through first. So enter vault is on vault account action. Vault accounts will call enter vaults with their address, the vault they want to enter, how much collateral they want to deposit, and this deposit must be in the primary borrowed currency, which maturity they want to borrow from, and how much they want to borrow, a slippage limit for their borrowing, and some arbitrary data to be passed to the vault to define how that vault how that account wants to enter the vault. So these parameters will largely be things like slippage limits, other types of metadata that the vault might require. This initial code block here largely just authorizes access to the vaults. So requires valid accounts. There's some configuration that allows vaults to restrict access to accounts, and perhaps do some sort of like pre-processing of transaction data before this method is called. So that's something that's checked here. There's a condition that some vaults may allow reentrancy. This is sort of a configuration variable that's only going to be activated for a handful of vaults that need to that lend on notional. So most vaults will probably be pursuing yield strategies outside of the notional system. Then we check some other sort of basic requirements here. And then we won't talk about settlement in this video, but when vaults have a matured position, they will first be settled. Now what will happen for vaults is the deposit amount will be first transferred to the vault directly, so we can take a look at that, and then the account will borrow the amount of Fcash requests, and we'll also transfer that to the vault. The reason we've done this in this way is to sort of just limit the number of ERC20 transfers that occur. So first we'll take a look at transfer underlying to vault direct. So what this does is it assumes that the notional proxy, has an ERC20 transfer allowance for the underlying token to transfer to the vault. So notional will essentially do a safe transfer from, or do a transfer from the underlying token directly from the account to the vault. Notional is going to record that this transfer has occurred, and then pass that along as we go further here. So the next method that we enter is called borrow and enter vault. Now it's important to note that accounts do not need to borrow. They can pass a 0 value in for Fcash. If that's the case, we just need to check that the maturity is valid. Now accounts might do this if they have a low collateral ratio that's getting close to liquidation. By depositing some amount of cash, they can raise that collateral ratio and get into a safer collateral ratio. So when accounts deposit, that deposit amount will be sent to the vault to mint additional yield strategy position. Now we'll take a look at borrow into vault. So this simply executes a trade on the notional AMM at the desired maturity and amount. That's going to update the AMM and push the interest rate up. And the hope here is that as accounts borrow on vaults at high leverage ratios, they will push the interest rates up, which will attract lenders who will be attracted to high fixed yield. That will push the interest rate back down, which will entice more users to come and borrow on vaults. So here what we'll do is we'll update the account's Fcash position. That is up here. So we will put the cash borrowed, this is in C token denomination, into this temporary cash balance. We'll update the account's Fcash position and the total Fcash position on the vault's state. And then we will update the used borrow capacity on the vault itself. So looking at this method, update, I believe it's up here. This method is fairly simple. We will just increase the total used borrow capacity by the amount borrowed, and if it exceeds the cap, we will revert. So borrows across maturity are just added together here. This is mainly like a heuristic, so we don't need to be exactly precise here. The reasoning is that Fcash in different maturities is typically not fungible, but here we just make that assumption. So we've updated the account, the Fcash position. We've authorized the borrow capacity. At this point, we've successfully borrowed, and we will assess any fees against that borrowed amount here. So assessing fees takes the fee rate and does a pro rata to the time to maturity. And we take that fee and we split it into the portion going to the reserve and the portion going to the end token. Once we've assessed those fees, we come in to this part, and what we'll be doing is we'll be entering the vault maturity. So when we enter the maturity, we will run a number of checks here to ensure that there's no asset cache in the vault state. So this is done to mainly ensure that we can keep the counting logic fairly simple. If there's cache inside the vault state, the counting becomes much more complex, and there's a lot more edge scenarios. Now the asset cache should be 0 in the vast majority of the time that the vault is in normal operating conditions. Only when a vault is has emergency exited funds, or when it's in the process of settling its debts as it gets to maturity, should there be asset cache in the vault state. So generally, users won't want to be entering vaults in those times anyway. We check that there is some temp cash balance, and that the maturities line up and set them accordingly. So there is a condition where vaults, may be rolling their position forward. In that case, there would be initial deposit of strategy tokens that we set first. This is something. This is somewhat okay. So this is something we'll describe more when we get to roll vault position. This doesn't really occur when entering the vault. Next thing we'll do here is we're going to deposit we're going to call deposit here, and we're going to tell the vault that we are entering a position for this account at this maturity with the sum of temp cash balance and the initial deposit, and the vault, the account wants to enter the vault in a particular way. So we'll take a look at that in deposit. So this method is fairly simple. All it does is transfer the borrowed cash from Notional, which, this is just a little bit of internal logic from the Notional side. And it's going to add the borrowed cash and the initial deposit in this method that's going to be called on this interface. So all vaults need to implement a particular interface and do, do particular things when this method is called. So it will return an accounting balance of the yield strategy tokens minted for this account. What we do there is we then convert that into vault shares and put those vault shares on the vault account. So we'll add them there, and we'll increment all the other variables. From there, we have the strategy tokens added. The vault account's position has been oh, right. Oh, let's get enter vault. So the vault position has been, or the vault account has been updated. So we'll set that in storage here. And the last thing we'll do is we'll check its collateral ratio. So let's take a look at that. So here what we'll do is we'll calculate the collateral ratio. So the first thing we'll do is we'll get the value of the account's vault shares. So that is calculated here. We'll get the account's claim on asset cash and strategy tokens. And we will get the value of those strategy tokens in underlying denomination. So here we'll convert that from the strategy vault's sort of underlying kind of like native token precision to 8 decimal precision, which we use internally. So that'll be returned here, and then we convert all of that into a C token denomination here. So this is the total value of a single account's assets. So then what we do is we get any secondary debts outstanding, and we add that to any primary debt outstanding. So that's our total debt outstanding. And then we do this calculation here, and that gets us the collateral ratio, which will be the net assets divided by the debt outstanding. So if that collateral ratio is greater than the minimum collateral ratio, then the account can pass this check here. And once that check is passed, then we're done with it. So now we'll talk about exiting a vault. So there are two conditions that an account can exit a vault under. One is post maturity, and the other is pre-maturity. So first, again, we authorize the vault, authorize the call, and the account, when exit vault is called, it can specify a receiver for the profits. That is not the same as the account address. Otherwise, it can specify itself. And it'll specify how many vault shares it wants to redeem and how much F cash it wants to lend, which is the equivalent to repayment. And there will be some data that is sent to the vault to instruct it on how to exit its yield position. Now, when the vault is exiting post maturity, the amount to lend and the vault shares to redeem are not considered. So once a vault has gone past maturity, the vault will already have sort of in pool settled all the debts owed by all accounts, and have repaid them. So in this case, the vault has a strict amount of tokens that it's owed due to the result of the settlement process, and we'll talk about that in a separate video. Those tokens will be fully sold in the vault, and all of the profits will be transferred to the receiver. So there is a condition which is so in this settlement process, it's also possible that the vault receive some amount of cash in return. So if it does, the receiver will also receive that cash. It is possible that during this settlement, the account will need to repay some debt. That is if the account has ended the vault maturity and is actually insolvent. Now, we'll talk about that a little bit more in settlement, how that might occur. But if it is the case, then actually this redeem with debt repayment will try to recoup the insolvency from the vault's wallet directly. It's unlikely that any accounts that are actually insolvent will actually call this method, and there's no way for us to force them to. So but this is there to handle that case. Now, what we'll do here is when we want to exit a position, what we'll do is we'll call lend to exit vault, and we'll take a look at that function now. So this is exiting prematurity, and when we exit prematurity, the account has the ability to repay their debt at a discount by exiting at the prevailing interest rate. So what we'll do here is we'll execute a trade. Now this trade is in the opposite direction from the borrow, and what it'll return is a negative amount here, which signifies the cost to lend an offsetting position of F cash. If that is 0, then lending has failed, and lending can fail due to lack of liquidity or interest rates that are too close to 0, causing the AMM to sort of underflow into a negative interest rate. So if that occurs, what we'll do is we will just give the allow the account to lend to notional at a 0 interest rate. So that is essentially, that's essentially what this does. Essentially, they're paying back their debt at face value. So we'll update the F cash here, and that's it. There are no fees assessed on exit. So the account now has a negative temporary cash balance of this asset cash cost to lend. And then we'll go into this strategy token or this exit maturity. Now, exit maturity is fairly straightforward. What it's going to do is subtract the vault shares that will be redeemed, and there will be some amount of cash and strategy tokens that are credited to the account. The cash is used to offset the cost to lend, and if there is any cash, that will be transferred back to the account. If there are strategy tokens that need to be redeemed, in this case, we will call redeem with debt repayment. So let's take a look at that. Now, this method is a little bit more complicated than depositing. But what's going to happen here is we're going to call redeem with a number of parameters. And we are going to calculate how much underlying tokens are needed to repay the C token denominated debt. So this is essentially some denomination conversion here. So we're going to figure out how much the account needs to repay. Now, there are a number of possibilities that can occur during this transfer. There are various scenarios where how we can enter this function here. But what's going to happen is that the notional is going to call the vault and tell it to redeem some amount of strategy tokens for this account at this maturity, and repay this amount back to notional to repay its debt. Anything in excess of this value will be sent directly to the receiver from the vault. Again, that's to save ERC20 transfers. So we'll detect how much has been transferred. And if the amount transferred back to Notional is insufficient to repay the debt, we will try to recover any unpaid debt from the account directly. So this gives the accounts an option of repaying a debt from their wallet rather than selling their yield strategy token yield position. Require that we have sufficient to pay, and then the last thing here is that Notional holds all of its balances in money market funds. So if the token type is money market, then we'll mint money market tokens instead of holding the underlying token, which is typically non-yield bearing. So that is redeemed with debt repayments. Again, we'll check the collateral ratio here. It's possible, right, that a user can redeem more assets than they repay debt, so we ensure that they stay within a safe range. And after this, we'll just sort of set a bunch of data. If the account has no position here, we'll actually clear its maturity before we set it. Now we'll take a look at the third and final action that an account can take, which is roll vault position. Not all vaults will be allowed to roll their position forward. Certain conditions need to exist regarding how the yield strategy is constructed, such that rolling is not going to mess up any accounting, and the yield position is actually fungible between maturities. But if that is the case, then this is a really nice feature that borrowers can have, which allows them to avoid settlement. So prior to the settlement process being initiated in their maturity, they can essentially migrate their yield position from that maturity to a new maturity. So there's a number of conditions that need to be met for rolling to occur. But what will happen here is the accounts, all of the accounts vault shares, its entire position, they have no sort of say in this, will be removed from their current maturity. So that means some amount of cash and some amount of tokens will be credited to will be taken out of that maturity. And what we'll do here first is call lend to exit vault. And what the account is going to do is incur a negative cash balance. Will incur a negative cash balance on their temporary cash balance. So we're going to put the costs to lend and debit that from their cash balance, so any asset cash held in the current maturity will be used to net off against that. However, generally speaking, the account is going to have a large negative cash balance here, and the way that they'll repay that is by borrowing from the longer dated maturity. So so what's going to happen here is that we'll call borrow and enter vault. There will be no deposit here, but there will be the account will then borrow some cash that will go into their cash balance, and some fee will be assessed against that as well. So once we do that, we will enter the vault. We will go through the entire process of entering the vault, borrowing the debt, entering the maturity. When we enter the maturity, we will check that the cash balance is greater than 0. If it's not, then the account hasn't borrowed enough to repay its existing debt and enter the new maturity. and then it'll go through the process of minting any additional vault shares that it needs. And when we exit this function, the account will now have a new debt position, a new vault shares balance at the new maturity, and no position at all in the existing maturity in their prior. So now we'll look at the various vault configuration parameters and administrative methods that are available to governance. So this is where vaults will start their life cycle. Vaults will start their life cycle by governance calling a method called update vault on vault action. This will whitelist the vault and set its initial parameters and its initial borrow capacity. So we'll just talk through what those are. So the borrow currency is one of the parameters in the vault configuration. We'll take a look at that now. So the borrow currency will be the primary currency that that a particular vault borrows. So that might be USDC, ETH, or DAI. It's also the currency that any profits will be paid in. The maximum borrow capacity is a absolute maximum on the amount of notional Fcash that can be borrowed across all active maturities in the vault. This is a way that this is a parameter that we will use to mitigate any sort of risk to the vault and risk to notional. There will be a minimum account borrow size, and this is a minimum size that accounts need to a minimum debt size accounts need to maintain to ensure that liquidations remain profitable. Yield strategies can get quite gas intensive, so what we will do is sort of measure the gas costs of liquidations and set appropriate borrowing size to ensure profitable liquidations. When vaults borrow, they will borrow at the notional market interest rates for a particular maturity, but they will also pay an additional fee, which will be an annualized percentage based on the total cash borrowed. So that fee will be split between N-token holders, which are liquidity providers on Notional, as well as the Notional protocol itself, which is, and that split will be defined by the reserve fee share. That's just a percentage. Now, vaults will also have minimum collateral ratio that sort of just defines where sort of the liquidation threshold. So the lower the the lower an account's collateral ratio is, the closer it is to liquidation. There will be a minimum deleveraged collateral ratio. So this is the collateral ratio at which liquidators will liquidate an account to. So this defines sort of the amount of assets that liquidators can purchase during liquidation. There's a discount rate given to liquidators as a profit, and a reserve fee share. There is also a configuration parameter which sets the maximum borrow market index. You can think of this as the maximum tenor at which vaults can borrow. So notional tenors go from 3 month to 6 month to 1 year to 2 years and on. Most vaults will choose 2 as a value here, meaning that 3 and 6 month borrowing is supported. At 1 year, we encounter this idiosyncratic, temporary liquid condition for Fcash, and that's something that not all vaults can probably gracefully deal with. So finally, there's the potential for vaults to need to borrow additional currencies that beyond the primary currency, and so those can be whitelisted here. We'll discuss what conditions accounts would or vaults would need secondary borrow currencies when we talk about those in detail. And with that, we'll also just take a look at the rest of the administrative functions available to vaults. So notional governors can pause the vault. When a vault is paused, accounts can no longer enter or roll their positions forward, so they cannot borrow more from the vault, but they can exit their positions, which causes them to pay down their debt. When a secondary borrow currency is whitelisted for a vault, it also has a max capacity cap, so governance can whitelist the max borrow capacity for the secondary borrows. And lastly, notional governors have the ability to call a method called reduce max borrow capacity. This will be used in emergency scenarios where for whatever reason governance thinks that the risk on a vault needs to be reduced. And so what will happen here is the maximum borrow capacity will be reduced, and some number of yield positions will be redeemed in exchange for cash that will be held on notional as repayment for its debt. So this is essentially like stopping out a position, stopping out a vault in whole. This is intended only to be used in extreme scenarios. Vaults generally will be required to codify the various emergency scenarios that can occur to them, and codify how they will sort of unwind themselves if those conditions exist. And we want to do that to ensure that there's a lot of transparency to vault users as to what conditions would cause this kind of emergency unwinding. So the last thing we'll talk about here is building a vault, and specifically the special vault methods that are available to strategy vaults. And we'll take a look at the strategy vault interface a little bit as well. So we've already discussed redeem strategy tokens to cash. This is how a vault can de-risk its position or enter or like begin its settlement process as well. So in this method, some amount of strategy tokens are redeemed in return for cash. Now there's an inverse of this method, which is for a vault to take cash that it's holding in its total asset cash position and mint mint strategy tokens as a result. Vaults can do this if there's an emergency condition that presents itself, which then that condition goes away and they want to put the cash back into the yield strategy. So that's what's available here. It's for vaults to use if they want to implement that. Note here that there is a collateral check that occurs here so that the vault does not like inadvertently put all of its accounts into liquidation zone. The rest of the special vault methods are related to borrowing secondary currencies. So borrowing secondary currencies adds a fair bit of complexity to vault design, and so many vaults may not need it. But some vaults, this is a feature that might be useful to certain strategies, such as providing liquidity on a kind of volatile, stable token pair. So perhaps USDC ETH providing liquidity on Uniswap or Balancer. In that case, borrowing only one of the currencies will expose a vault to large amounts of impermanent loss. But being able to borrow both USDC and ETH in order to enter into a liquidity provider position will significantly reduce the amount of impermanent loss exposure it has. So this feature is here for just vaults that need it. The way vaults will use this functionality is that Notional will execute the borrow in the primary currency first, and then vaults will then come and call back notional, call borrow secondary currency to vault, and borrow the secondary currency. So in our example, perhaps USDC is the primary currency. The user will specify how much USDC they want to borrow, and the vault will determine how much ETH it needs to borrow on behalf of that account in order to complete sort of the yield strategy, entering the yield strategy. So the vault is going to call this borrow secondary currency to vault method, and accounts will and it'll sort of execute the borrow accordingly. Now there is the condition where these debts may need to be rolled forward. So we detect that here, and we sort of roll that position forward. So we'll take a look at how these secondary borrows work. So secondary borrows work in some ways similar to how notional vault states work. Let's find this code real quick. Increase secondary borrow. So what we'll do here is first we'll update the used borrow capacity and detect if we've exceeded the maximum secondary borrow capacity. And then what we'll do is we have a calculation which is called account debt shares and total secondary Fcash borrowed. So what an account actually has is a share of the total debt borrowed in the secondary currency. The reason for this is that when an account reaches settlement, it also needs to do a pooled settlement of its secondary debts in whole before it can settle. So marking what an account has borrowed at its notional value on the account is going to be inaccurate if that debt will be repaid as in a pooled nature as the account reaches settlement. So what the account actually has is what we call debt shares, which is sort of like a claim on the secondary debt borrowed in that secondary currency. So calculate that using some kind of math here, and we update that on the account and update that on the balance as well. The secondary currency trade is fairly similar. There's a little bit of extra handling to figure out repayment post maturity, as well as force it to lend at 0% interest rate. When the lending trade fails. So that is increasing secondary borrows or borrowing secondary currencies. Similarly, the inverse of that is repaying secondary currencies. So when this occurs, the vault is also going to make this call. We authenticate that it is the vault calling. There will be some amount of debt shares to repay. So we'll calculate how much cash that costs to repay the secondary borrow. What we're going to do here is sort of optimistically execute the lending action and update all of the accounting internally, and return the cost that the vault needs to, the cost of that lending action from the vault. And what the vault is going to do is, what we're going to do from here is we're going to call back the vault and have it return this amount of cash to Notional. The reason for this is dealing with the notional AMM can lead to various like off by one errors and things like that. So this is sort of a gas efficient way to ensure that we don't have to do one pass through the liquidity curve in order to figure out how much the vault needs to repay. So that will reduce an account's debt. This method can also be used to repay the secondary borrows in a pooled nature during settlement. During the settlement method, we also need to snapshot the value of those secondary debts before we start to settle. So this is something that is required in the settlement math when we go through the settlement process. So you can see some of that math in this secondary borrow adjustment. We need to take a look at this total F cash borrowed in primary value, which is snapshot once. So that's that logic is similar to the settlement logic that we have where we have to snapshot valuations in order to apportion assets appropriately. So vaults will need to call this initiate secondary borrower settlement once in order to kind of begin to complete the settlement process for secondary borrows. And that concludes a discussion of settlement secondary borrow currencies.